Finally, we'll practice constructing polynomial models for some applications. A shipping container in the shape of a rectangular solid must have a volume of 84 cubic meters. The client tells the manufacturer that the length of the container must be 1 meter longer than the width, and the height must be 1 meter greater than twice the width. What dimensions of the container should we make? All right, so let's think about some phrases here that are probably pretty important. So the length has to be 1 meter longer than the width. And here we have something about the height must be 1 meter greater than twice the width. And we know that the volume has to be 84 cubic centimeters. So just as a reminder, the volume of a rectangular solid is the length times the width times the height. And we're given some information. The length has to be 1 meter longer than the width, so the length is going to be the width plus 1. The height has to be 1 meter greater than twice the width, so the height is going to be 1 meter greater than twice the width, so twice the width and 1 meter greater. And then the width, of course, is the width. And that's the volume, and the volume is 84. So what we would do is we would go ahead and we would multiply these values together. So let's just go ahead and start doing that. And if you want, you can rearrange them because the arrangement is a little awkward the way we have it written so far. So I'm going to rewrite the order. And then I'm going to start by multiplying these polynomials together by distributing, or however you like to do that. That would give us 2w squared plus 3w plus 1. And finally, multiplying all those by w gives us 2w cubed plus 3w squared plus w. Now, in order to be able to solve, I'm going to need to have it equal to 0, so I'll also subtract 84. And so here is the polynomial that models the size of the shipping container. And again, I would use technology since this isn't in factored form. You might say, well, it was in factored form and then you messed it up by multiplying everything together. That's true, but remember when it was in factored form, it wasn't equal to 0. So factored form really doesn't help us unless it's equal to 0. So that's why we really did have to multiply them together. And now we have one side equal to 0. What we would do next, because it's a cubic, is to use technology and find our roots. Let's take a look at another example. A rectangular box's length is 3 inches longer than its width. The width is 2 inches more than the height. The volume is 120 cubic inches. Find the dimensions of the box. So again, it's a rectangular box, so the volume is going to be the length times the width times the height. So what are we told? We're told a couple of things. We're told that the width is 2 inches more than the height. Okay, so the width is going to be the height plus 2. The volume is 120. Here was something we were told that I just skipped over. The box is 3 inches longer than the width. So notice that if I did the length being 3 inches longer than the width, if I wrote this, then I'm going to have two variables in the problem, and I'm not going to be able to solve. So even though that would be the easiest thing to seems to do, I mean 3 inches longer than the width would be written this way, I can't do that because I would have two variables in the problem. So what to do instead? Well, I already have an expression for the width. I already know that the width could be h plus 2. So what would be 3 inches more than that? It would be h plus 2 plus 3, or in other words, h plus 5. And then, of course, the height is h. So again, let's go through that one more time. The length was 3 inches more than the width, so if the width was h plus 2, 3 inches more than that would be h plus 5. So now we have an expression in one variable. It's nicely factored, however, it's not equal to 0. So even though it's nicely factored, having it in this form is not going to help us. So we need to start multiplying these together. So h squared plus 7h plus 10 times h. In other words, h cubed plus 7h squared plus 10h. And then I would subtract 120 from both sides to make one side equal to 0. And now I have a polynomial that I could find the root of using technology. Here's one for you to try. So just see if you can set up the polynomial equation needed to solve this problem. You don't have to solve it, unless you want to. So a rectangular box is constructed with length twice as long as the width and height 2 inches more than the width. The volume is 192. Find the dimensions of the box. So I'll help you get started. The volume is equal to the length times the width times the height. We're told that the volume is 192. And then you just have to go through and pick out these phrases that you know are important. So the length is twice as long as the width. So that gives you something to fill in here. And the height, 2 inches greater than the width. So that gives you something to put in here. And we have the width is W. So go ahead and fill those in, make one side equal to 0 and simplify. And then you can check your answer.